Okay, all right. Sorry, I forgot about recording. So the next slide. And I know at this point Syra won't be here because she had another meeting she had to be at 7. So I guess we'll just go on without her, which is too bad. I hope we can get her back sometime because she has a lot of good things to say. So let's go on to the next slide. There we go. All right. So yeah, so all right. Yeah, someone said I like that word bipartisan support, and that's part of what the work. There was bipartisan support in the late late 60s, early 70s because people all let their elected representatives know that environmental issues were important to them. Clean water was important to them. People like Marion started out, organizing people about that. So as I said, the Richard Nixon's 1970 State of the Union address, in the middle of the Vietnam War, right? He had less than 100 words on Vietnam. He had more than about 1,000 words about the environment, which is pretty, pretty amazing when you think about it. But also that same speech, he talked about a war on crime. He attacked the welfare system. He helped propel a lot of the racialized politics. And as some people have, studied Richard Nixon more in the past, they realized that he saw that he saw the environment as a cause for the white majority that he supported. And that was kind of borne out in a 1972 poll of the Sierra Club, where they polled their members and wondered if the Sierra Club should concern itself with conservation problems of such special groups as the urban poor and ethnic minorities. And that was their actual wording, which kind of says something too. And when they did that, 42% of the people who belonged to the Sierra Club were strongly opposed to that. So think about that. In 1972, people were seeing the protecting the environment not part of the urban problem, urban need. So only 15% were supportive. And I didn't learn that until I don't know, last year sometime. I was like, wow, that's pretty amazing. So and so that's where we come from. So if we go to the next slide, and I think we're going to skip over the slide for now. So I think we'll go on and for a little bit and then do a break instead. We'll come back for our break. So because I want to talk about colonialism, because a lot of this, really comes back to colonialism. And I'll send you, these pictures so you'll see them in more better. But what this is, the slide on the top left shows deforestation in Indonesia from all sorts of different land uses. And so this is really, it's resource extraction. So we're growing palm oil in Indonesia that they're exporting to us to use. They're growing they're mining things there, so they're cutting trees down to mine. They're drilling for oil and gas, so it's really it's a mess. And so trees, we lose trees that way, and so this still is extractive colonialism going on, as we know, all over the world. And Indonesia's forests are a good example. The slide to the right next to that shows that where settler colonialism is still a reality. We're settlers here, and there are places around the world that there are still settler colonialism is still strong and good, strong for the people who are benefiting from it. But there's also something going on now, which is a kind of a re-indigenizing, and you can see that's the darker gray areas you can see in Africa and Greenland. So, and this slide was actually produced. It's from a group that shares information about the Palestinian problem, and so they're the people in the Palestine are they're experiencing pretty active settler colonialism going on right now there. So, and then the bottom one is just an example that in addition to countries and people, and now instead of the religion, going out and claiming the name of, the land, the name of His Majesty, or like they did during the Crusades, now we're out claiming, we're playing games with monetary systems, and that, the World Bank, International Monetary Fund, they all help control what happens by controlling who gets subsidies and who doesn't. So it's just something we really need to be aware of, and to think about as we go forward, that there is, there are winners and losers in almost everything. And you have to see who the winners are and what they're getting, and who the losers are and what they're losing, and then advocate for what needs to be done. And all these links I'll be sending out. Someone asked, but the links will all be available on our Google site, and then the additional information I'm sending out. So you'll have that. So it's something, it's something to think about. There's a lot of, there's a lot of writings now about, neo-colonialism, like the reason, one of the reasons we have so many problems with refugees from Central America and, coming up to the United States is because the banana republics are real. The United States impacted these communities, these countries in the 18th, 19th, and early 20th century. And even now, we know that the United States, the Iraq War, we are, there are a lot of things that impact people. And when there are wars, when there's economies that are run by corporations and not the indigenous people have bad lives and need to look and go somewhere. So think about, that's just something else for us to all to be thinking about as we go forward. And there's a lot of, it was really, this was the hardest week for me to put together because there's so much information. So I'm going to be sharing a lot of information with you in the additional information. And so feel free to look through some of the articles I'm sending, and if they interest you. So, but next we're going to talk about Robert Bullard, who is someone who, we can go to the next slide. We're going to watch a video first about Robert. I think Lily's probably set up the video right now. So, because we've been having a problem with sharing the PowerPoint slides.
It keeps dropping embeds. All right, screen share. There it is. And sound's on. Okay.
All right.
Ready?
Yeah. Oh, good.
It's really important that communities have researchers and scientists that they can call upon to assist and support. And so over the years, we have these community university partnerships, and that's what I've been part of and have been pushing for the last 4 decades. Environmental racism kills. It makes people sick. The environmental justice movement grew out of the fight for civil rights and human rights. When we bring them all together, it's just one movement, the movement for justice. My name is Dr. Robert Bullard. I'm a distinguished professor of urban planning and environmental policy at Texas Southern University. My job is to connect the dots between who gets what, when, where, and why when it comes to pollution. In 1978, what I found was that 100% of all the city-owned landfills were located in black neighborhoods here in Houston, Texas. I was able to document that the same pattern that we discovered in Houston was happening all across the South. And that's how the book Dumping in Dixie, Race, Class, and Environmental Equality was published in 1990. That was the first book on environmental racism and environmental justice. And what Dumping in Dixie research revealed to me is that it was not accidental, it was not coincidental. Systemic racism created these unequal, invisible communities that received the worst of the worst. And as I discovered, it was not just a Southern thing. Environmental racism was a national phenomenon. And as a matter of fact, it's international. Before COVID-19, communities of color were inundated with all kinds of environmental hazards and disparities. COVID-19 brought to the surface the underbelly of what systemic racism is doing. We have 2 pandemics that's happening at the same time, the COVID pandemic and the pandemic of racism, and they both must be attacked at the same time. Act for nature, for humanity.
Okay, good. So that was last year. Last year, Professor Bullard won one of the UN awards for the contributing to the environment. And so, and he's someone who, in 1990, he was just a sociology professor whose wife was doing a lawyer, and she was involved in one of these a court case where people were trying to fight a landfill that was being proposed in their community in Houston. And it was through that he got into all that research and learned about all this. So, it's just interesting how these things evolve and develop. And so we're going to go get back to our slideshow now. And so, yeah, so just again, this is Houston, one of the biggest cities in the country in 1978, and only 25% of the people were Black, but all the city landfills, 3 of the 4 privately owned landfills were in Black neighborhoods, 6 of the 8 city-owned incinerators were in Black neighborhoods, and more than 80% of the garbage in Houston was being disposed of in Black communities. So that's, that's kind of tells you a lot of big story there. And it would be interesting to see those other areas if they were just poor white areas, because you can see this quote from Dr. Bullard below, which basically says, not that all issues of environmental racism and environment don't need to deal with people of color. We're just as concerned with inequities in Appalachia, for example, where whites are basically dumped on because of a lack of economic and political clout and a lack of having a voice to say no, and that's environmental injustice. So, yep. So I see someone in Anna in the chat said the Gardner wants to expand their sludge landfill in West Gardner, and that's a big low-income sludge population in that area. So this is still going on right now, and I will briefly share my story with you. I was involved in fighting environmental injustice in the Winchendon and Gardner areas in the early 1990s. In a span of about 3 or 4 years, there were 3 huge projects that were proposed. One was, at first, Boston wanted to put an airport to replace Logan Airport. And they had landed on 2 sites. One was Devon's, and one was like the Winchendon, Gardner, Templeton area, because there were a lot of woods there that weren't developed. So we fought that. We worked together. My parents lived in Winchendon at the time, and we and our neighbors all had to organize, get together, educate ourselves. We banded together with people from the Devon's area who also didn't, saw that an airport serving this huge a problem was going to change the character of our communities. It was going to change life as we live here in North Central Mass. And so, and we also saw that it wasn't needed, because at the time, it's kind of sad now, because some of the things we were pushing for at the time, we still haven't dealt with. The whole issue of high-speed rail was, and I forget the numbers at this point, but like at the time, like 40%, 30 or 40% of the flights out of Boston were going to New York City or Newark. And so we said, hey, can't we do high-speed rail instead? Or we hadn't, can't we consider how we can use other local airports? Or, isn't this new computer technology going to bring video conferencing to the world that will cut down on travel? So those are all things that happened. So soon after they realized that they did not need to build a second major airport, BFI proposed to build a 1,500 ton per day landfill in Winchendon. And again, this was not, Winchendon wasn't producing 1,500 tons per day. This was coming from the greater Boston area. And so again, people, just ordinary people had to organize, raise money to, print flyers, get organized for town meetings. And that one, we also, we won basically because our group appealed a wetland determination. And I guess BFI made a decision that, it wasn't worth the effort to get into at the time, wetland appeals were taking a couple of years and they just didn't have time to wait. So they withdrew that. And then soon after that, a couple of people from the closer to Boston, the 495 belt, proposed building a major drag strip, like a 30,000 people, Epping, New Hampshire type drag strip, again, in the Winchendon Gardner area. And that, again, we had to organize. And this is all within a matter of 3 or 4 years. So it was, it was a hard time, and I'll share, it's hard because you have to, you're trying to deal with your regular life. At the time I had a bunch of young kids. I was working part-time. My mother was battling cancer, but you had to find time in your life to deal with all this stuff. And so if you think about, and I had the privilege of that on my days off, my parents were around to watch my kids, so I could go and spend my time, running the appeal to DEP on the wetlands permit. So I think it's important to think about how that feels when a place that's special to you is threatened like this, and particularly when you have no voice. So anyways, 25 years later, I found myself in a meeting with some of the same people that were involved in those 3 fights, because Kinder Morgan was proposing to build a huge gas pipeline through the same area for the same reasons. They thought, people in Winchendon, Ashburnham, Royalston did not have the political clout to say no. They couldn't be organized. And so, anyway, I spent the next 2 years doing with that. So I get the environmental, I don't get the racism part because I haven't experienced that personally, but I get environmental injustice because they don't propose things like this, even in Harvard or in Concord, right? They're proposed in places like Winchendon and Templeton and Gardner. And so I think it's for all of us to realize that. And so the next time, one of the reasons that I was interested in organizing people in this region is because the next time a big proposal comes along, we want people to be ready to know that we have to get organized, and it saves you a step at the end. And hopefully, as we build back better from climate, we can decide what we as people in the region want our region to be like, rather than having someone who has a lot of money and consultants from outside an area wants to put in our area. So with that, I think we'll stop for a second and talk, and we can go back. Lily, why don't you go to the slide? Oh yeah, we can just talk first. That's good. Yeah, that's good. So any questions? Or I just basically wanted you to know that there are a lot of good online tools available to help us look at what peoples are being affected. And one way is one tool the Massachusetts has, a environmental justice population map, which basically does income, the non-white population, and limited English proficiency. And the EPA has an environmental justice screening tool that covers a lot of categories. It covers a lot of the demographic categories like Massachusetts does, but it adds things like people who are under the age of 5 or over the age of 64. And so it also covers a lot of environmental categories and people's exposure to different types of things, including air toxics, particulate matter, ozone, lead paint exposure. So these are really good tools for people to use, not just in environmental work, but like if you're writing a grant for something, that you can access these tools and find out how many people are, say you're trying to do a housing rehabilitation program. They can show, you'll find the maps for lead paint. So let's go on to the first map I have is this is just something I just did and took a screenshot of, and this is the Massachusetts map, which shows the minority population, and these are all done by census tract. And so the colors that show up, the orange is a minority, the light green is a income, and then the darker green, like you see in Leominster and Fitchburg, is minority and income. And then there are other colors that show up in other places in the state, like if you look up at Lawrence, up in the top right corner, you'll see they have some pink and blue ones, which are minority and English isolation, meaning not English speakers.
Can you move the legend bar over? Because it's
no, I can't. No, this is just a screenshot. So I'll send you the link so you can go play with it yourself. So rather than try to do that, we'll go on to the next map, the next slide. And this is, again, just a screenshot I took of playing with the EPA screen, where I could draw a circle which is the one in the green area that encloses the green area of north central Mass. And then I can pick a buffer around it, which it drew automatically. And this is, I picked lead paint exposure. So the lead paint indicator is based on how many houses, the percentile of homes that were built before 1960, which is an indicator for lead paint. It doesn't say that, it doesn't seem definitely lead paint because some of them may have been deleted in the past. But as you can see, the areas that had the high environmental justice scores on the Massachusetts website also show up here for lead paint. So this is, again, an example. But then again, if you look at this, one of the ways that this sometimes can be used inequitably is you could look at perhaps a neighborhood in Newton, Mass. That might show a lot of the homes are built before 1960. And so if you have a program being proposed that is going to take care of lead paint, you want to also make sure that it adds like or you would want to advocate for maybe some sort of economic need, as well as just the home being old. So people who can afford to de-lead their homes can, and the people who need help de-leading homes also can get help to do that. So just wanted to show you that. I'll go on to the next slide. And again, I'll send you the links to all this. And so you can play around with it yourself. They're very, you can play the mapping game. So yeah, so the traditional golden rule is, treat people the way you want to be treated. And today's golden rule is the one that Hal's told us a couple of times. It built up the gold rule. And then, the tomorrow's golden rule is what we want. What do we want? And one of the things that people in environmental justice talk about is they want environmental justice, not environmental equity. So environmental equity would be poisoning people equally, and environmental justice is stop poisoning people, right? So, so let's go on to the next slide, which we're going to talk about corruption quickly, because corruption kills, because and a good example, two great examples of that is what has happened with the tobacco industry, when they knew the tobacco killed, but they hid the data. And we found out that the exact same people who were involved in tobacco cover up were hired by the fossil fuel industry to cover up climate. So for all these years that, and you may have seen the article that came out at the beginning of this month, where Exxon, an Exxon lobbyist was caught lying, not caught telling the truth to an undercover journalist who worked for Greenpeace, pretended to be someone wanting to hire a lobbyist, and they got him to explain how they knew about the climate science and how they've worked to lobby against climate for all these years. So this is, one example how, corruption kills, and corporations that are corrupt kills. And this is one of the reasons that people are so irritated that the fossil fuel industry is still getting government subsidies for a lot of their work, even though they have lied and they have killed. So, and this is something that's, people are making proposals in Congress now to stop that. So the next slide, look at that. And again, I'm going to be giving you a lot of information about all this stuff because I had way more information I could cover here tonight. So you'll have a big document just coming up this week. And then I also wanted to talk about diversity. And the diversity is important because diverse viewpoints and experiences are important. Just like we talked about, like in the early environmental movement, early anti-pollution movement, some choices were made that may have benefited people in Boston getting water, but it didn't help the mill owner in West Boylston whose mill was destroyed, or the many farmers and whole communities that were destroyed. So the more, if those farmers had a voice at the table, maybe something would have been done differently. And so it's important to get diverse viewpoints at the table. And that's why it's important to realize that a lot of the people who were running some of the environmental organizations in the past were not diverse. And the more we can get more diverse people involved in things, the more diverse experiences we can share, the better the outcome can be. And this is just an example, you know, the old elephant example. You get a lot of people to look at one part of an elephant and it doesn't look like an elephant, but when they all come together and tell their own story about what it looks like, then all of a sudden it becomes an elephant. So, okay, so Jason's saying that Massachusetts just updated our definition of environmental justice. It was signed into policy in June. Oh, good. And the GIS layer should be updated soon. Thank you for that, Jason. I'll share that link. So next slide. Which also, Jason might be better speaking about this than I am because of having lived in Africa. But when we talk about what we can learn from other people, Ubuntu, is that correct, Jason? Did I pronounce that correctly, I hope? Ubuntu is a, I don't know what to call it. It's not, like they said, it's very difficult to use in a Western, it's a way of being, I guess. And the story that is shared with this is a sociologist or an anthropologist was visiting a community in Africa and had a bunch of candy. And so he put the candy in a basket and put it by a tree. And he told this line of kids that, you know, whoever runs to the tree first and gets the basket can have all the candy. And what the kids did is they all, you know, they all ran together in a line, sat down, grabbed the basket, put in the middle and sat around it, and they all ate the candy. And it's because they were brought up to believe that, you know, that they are bound together, and that I'm successful when you're successful. And so Ubuntu is that theory. So Tamara, do you have your hand raised, I see?
This is a saying that's very near and dear to my heart. I actually, oh, thank you. I actually started a mission called Ubuntu. And our definition, the way that we explained it to people, because it isn't translatable, is it's basically, it takes a village to raise a child, but it also takes that common kindness and empathy to be able to flourish. So if you're looking at common kindness and empathy to everyone, then the whole community thrives versus one small section of that community thriving.
Great. Well, thank you. Yep, that's Ubuntu. Is that how you pronounce it? Ubuntu? I wasn't sure, but I think it is an interesting. You know, it's something for us. Just like, you know, some of these stories that Indigenous people had that were squashed because we did not value Indigenous people have value for us today, I guess is what the takeaway from all this is. So with that, we're going to jump into the next slide, which is the project drawdown slide. And this is a little bit longer video today, but it has an important one about how we reduce sources. So when we finish that, we'll stop the recording and gather up again. So.
Okay, so now we're going to talk about reducing the sources of greenhouse gas pollution. I already told you that this is going to be key to addressing climate change. We're going to stop the problem before it even gets into the atmosphere. And that's the way we need to begin. So we're going to zoom in and look at all the different contributors to the sources of greenhouse gas pollution and how we can bring these things down to zero and stop the problem in its tracks. Well, what are the sources of this greenhouse gas pollution to begin with? Well, you've heard of a few of them, but some of them are going to be kind of surprising. One of the places we should begin is the biggest emitting sector of greenhouse gases, which is making electricity. It turns out that burning coal in a power plant or natural gas creates carbon dioxide, and that is a big contributor to climate change. Overall, across the world, it's about 1/4 of the problem. In some countries it's bigger, in some countries it's smaller, but the globe as a whole is 25%. The next biggest source of greenhouse gases often surprises people, and it's 24%, is food. It turns out that growing food and agriculture and the land use associated with all of that together is about 24% of our emissions. Isn't that weird that electricity and food are about equal and together are half of climate change? We hear a lot more about the electricity space, though, than we do the food space. It turns out they're about equally important. Then we switch over to industry, kind of making all the stuff in the world. We'll go through a lot of those different things, but making steel and cements and plastics and other things, as well as managing waste, is what's happening here, and that's 21% of the problem. Then we've got transportation, moving us and our goods around the planet, whether it's a car, a truck, a plane, a ship, and whatever, that's about 14% of the problem. Then we go to buildings. Buildings cause about 6% of climate change. But to be fair, buildings also are using a lot of the electricity. They're responsible for some of the industrial emissions to make the components of buildings. And of course, transportation takes us from building to building. So buildings directly, from their furnaces, their hot water heaters, boilers, and air conditioners, emit greenhouse gases, but they have a big effect on a lot of the other sectors. So how we build buildings and what we do with buildings and the design of cities is crucial throughout all of those wedges of our pie chart. Then we've got the remaining 10%. That's a lot of different things, but it's actually dominated by the energy industry. It's going to be responsible for things like fugitive emissions, the kind of leaks of methane and natural gas that aren't intentional, or when they flare off natural gas in an oil well, or the emissions when we refine crude oil into things we use like diesel fuel, gasoline, and so on. So energy industry and a few other things show up in that last 10%. But look at the first 5. It's kind of amazing that only 5 things, electricity, food, industry, transportation, and buildings, cause 90% of climate change. Well, heck, that's just one hand. We can solve 90% of the problems with just this. That's pretty good. So let's go through each of these sectors and kind of see what can we do to reduce these emissions and eventually bring them down to zero. So we're going to look at each sector, and then we're going to dive into particular solutions, and we're going to show you how at Project Drawdown we've tried to estimate the size of these different solutions and which ones might work best. So let's start with electricity. Electricity, again, produces about 1/4 of the world's greenhouse gases. And the production of electricity burning fossil fuels, especially coal and natural gas, causes those emissions. But we can also look at how electricity is used. Most of the world's electricity is used in buildings for lighting and air conditioning, heating, refrigeration, all those kinds of things. And about the other half or so is used in industry, making stuff, big industrial, big machine processes. The rest is about 2% that's used in food and transportation and everything else. So buildings and industry are the big users. Well, let's make this kind of real. Burning coal and natural gas in a power plant is what produces these emissions, and that's what makes electricity, and sometimes we use the heat in a power plant for something else as well. We take that electricity, we put it in buildings, industry, and everywhere else. And the kind of electricity we make is associated with the electricity that's in the grid, but also the greenhouse gases we put in the atmosphere. For example, burning coal releases about 2 pounds of CO2 for every kilowatt hour of electricity we use. Natural gas is a little less. It's more like 1.2 pounds of CO2 for every kilowatt hour we produce. Then we have solar, wind, nuclear, and other forms of making electricity that don't produce any CO2. So this is a big difference between the fossil fuels electricity and the non-fossil fuel electricity. It's a huge, huge difference. Now let's make this real. A kilowatt hour is what we use to measure electricity consumption. A kilowatt hour is like using 1,000 watts for 1 hour. A hairdryer uses about 1,000 watts. So if you turned on a hairdryer and left it there for an hour, that's 1 kilowatt hour of electrical use. Pretty simple. Well, the average American home uses 1,000 kilowatt hours every month, on average. Some use more, some use less, for all the different things we use electricity for. Well, if we do the math, 1,000 kilowatt hours on America's electrical grids, which releases on average about 1.4 pounds of CO2 for every kilowatt hour, that means an average American home is responsible for over 16,000 pounds of CO2 pollution, or over 8 tons. That's incredible. How would we reduce that? Well, we already kind of know, don't we? We can have energy efficiency. We could reduce the use of electricity. No matter how the electricity is made, we could probably cut it in half with better lighting, better air conditioners, better appliances, and so on. But then we can also switch the way we make electricity to things like renewables that don't emit any CO2 at all. So that 1-2 punch of efficiency and transforming to renewables is key here. While drawdown, we looked at those solutions not at your home level, but at the larger economy level, at the whole planet. And we looked at a whole bunch of solutions that could enhance efficiency, many of which are in buildings and automation, are all listed here. And we also looked at ways we can shift electricity production away from coal and gas to things like solar and wind, hydro, geothermal, biomass, nuclear, and beyond. We also have to do a few other things, by the way, like improving the grid. We have to have electricity dispatched and stored in new ways to accommodate renewables. And we also have to have more flexibility in how electricity is used. But if we put all these things together, a whole bunch of efficiency solutions, a whole bunch of solutions about producing energy in new ways, and improving the grid, we have an enormous suite of climate solutions right here in electricity. In this picture, each of those solutions is represented by a single circle. The bigger the circle, the bigger the climate solution. Some of those circles actually have two rings, an inner one and an outer one, and that kind of represents a range of estimates we've made about how big that solution could be over the next 30 years or so. So there are a lot of good solutions here in efficiency and making electricity in new ways. Really exciting. Well, let's look at food. Food's also a big emitter of greenhouse gases. Again, about a quarter, 24% of our emissions come from food. A lot of folks, though, think the food emissions come from things like moving food around or food miles you might hear about, or if we grow food maybe organically or with conventional ag or GMOs. We talk about that stuff all the time, but it turns out those aren't the big issues. The really big issues in agriculture emissions for climate change are actually three other things. They're deforestation, kind of burning down forest for new agricultural land. Most of the deforestation on the planet today is happening in Brazil and Indonesia and a few other countries. In Brazil and Indonesia, we're clearing a lot of land for cattle and soybeans that are used to feed animals, mostly in Brazil. So animal agriculture is hugely responsible for deforestation there. In Indonesia, it's mostly for palm oil, being used as a cooking oil, mainly in China and India, but also used as kind of an ingredient in a lot of other foods. The next big area is methane from our animals and a little bit from rice fields. And again, animal agriculture is really important here because cattle and cows burp methane, as we talked about before, and that methane builds up in the atmosphere, causing a big level of new climate change. Basically, we're gonna have to rethink meat and dairy products in order to reduce those emissions, either having a lot less of it or growing it in really different ways. Then we have nitrous oxide, that gas I talked about before, which is often produced by using fertilizer too much. Whether that's fertilizer that's chemical fertilizer or manure, they both have nitrogen in them. And if we put too much on a field under certain conditions, that nitrogen can come off into the atmosphere as nitrous oxide, a major greenhouse gas. A lot of the rest, by the way, will run off into the water and cause pollution in streams and watersheds and lakes and even entire oceans. So managing nitrogen and fertilizers is going to be a real big problem, both for climate change, but also for ecosystems and our water. So to solve those problems, we can again look for efficiencies, things we can do to reduce the pressure on the food system. It turns out the biggest place to start is food waste, because we throw away about a third of the food grown on the planet. Food waste is so crazy. In rich countries, we use far too much food and throw away a lot of it, and it's never even eaten, and that's just tragic. In poor countries, though, food waste is often about the same number, but it happens closer to the farmer, because maybe the crop didn't get to the marketplace, maybe it rotted in storage, or it never got on the truck, or the train broke down. So we lose food there too, and the farmer loses their income, kind of a double tragedy. So food waste is actually a huge problem, not only for climate change, but food security and a lot of other things. It's a problem worth solving. We also have to think about diets. I showed you how meat and dairy products were responsible for a lot of the big drivers of these emissions. So eating more plants and less meat-based products is a really simple, kind of easy, duh thing to do. If meat and dairy are responsible for a lot of emissions, let's eat a little less of that stuff and then grow what we do eat better. We also have to protect ecosystems from being cleared. Can we put up big fences and just say no to deforestation, stop them in their tracks? Make sure we don't clear forest, and especially forest with peatlands under them that have carbon in the trees, but carbon in the peat below ground. But then finally, we can also improve the way we farm on the lands we still are farming. That's going to be a whole bunch of different things about using water better and nutrients better, tilling the soil less, putting on cover crops, all sorts of things. And you'll hear a lot of excitement about regenerative agriculture, which kind of mimics nature's way of doing things as we farm. Regenerative agriculture and these other farming practices can reduce emissions a lot, and that's really crucial. Later, we're going to talk about the potential of some of those farming techniques to not only reduce pollution, but also create new carbon sinks that might absorb CO2 and put it into the soil. That's pretty cool too. But for now, we're just talking about reducing the emissions from farms. Well, let's put all this together. It turns out by looking at all the food solutions, we see food waste is huge. Changing our diets can be huge. Protecting ecosystems, especially forest and forest with peatlands below them, are really important, and farming differently is a major contributor too. So the solutions to the food system climate problem are partly due to us, partly things about ecosystems, and partly what's happening on the farms. We can all do our part here. Well, then let's flip to industry. In industry, we make a whole bunch of things that take high temperature, very intensive processes to make, like metals, especially steel. Steel is a big contributor to climate change. Cement. Making cement releases a lot of CO2 into the atmosphere. Our chemicals, and also plastics, things like that, each make some CO2 as well. By the way, we hear a lot about plastic being a big climate problem. It is. It's about 1.5% of climate change is tied to producing, using, and disposing of all the world's plastic. Definitely a problem, but it's even more of a problem out in the larger environment because it's affecting marine ecosystems and causing pollution all sorts of other places too. And then finally, managing waste. And the gases used in managing waste, but also released from landfills, is crucial. We're going to look at that too. So we're going to look at all sorts of industrial processes, manufacturing and materials, and how we process and manage waste across all of those different domains. At Drawdown, we've looked at a few already and put numbers on them, like what can we do with cement, what can we do with plastics, and then we look at a specific suite of chemicals called refrigerants, which are all these fluorinated gases. It turns out that fluorinated gases like chlorofluorocarbons are very dangerous. Back in the 70s, we realized that chlorofluorocarbons were actually hurting the ozone layer way up in the upper atmosphere. They also contributed to global warming. But we phased out most of those chlorofluorocarbons and replaced them with hydrofluorocarbons, or HFCs. Those don't hurt the ozone layer, thank goodness, but they still contribute to climate change. So they're ozone friendly, but not climate friendly. We're going to probably have to replace them again and replace them with climate friendly refrigerants and make sure that none of the existing refrigerants leak and get into the atmosphere. We've also looked at ways we can use waste as a resource. Rather than throwing something away and never using it again, the kind of recycling, repurposing, and actually using energy from our waste streams is a really clever idea, which makes just all sorts of sense. So if we think about improving materials, especially refrigerants, and using waste as a resource, we have a lot of solutions already appearing in the industrial sector. We've got a few more to work on, especially steel and a few other things, but we've got a good start here. Then we got transportation. Transportation is about 14% of the problem. Most of that is on road transportation. 10 of that 14% is in roads, cars, trucks, things like that. The flying we do, aviation, is a little less than 2%. That's all the commercial and military aviation on the planet is about 1.8% of global emissions. Everything else is another 2% or so. That's going to be ships and trains and other things. But mainly it's roads, planes, and the rest. CO2 is made here, that's pretty clear, by burning the fuels we use in transportation. Gasoline, diesel fuel, jet fuel, when we burn these liquid fuels, it releases carbon dioxide into the air. Well, let's take this to everyday life. Like imagine a gallon of gasoline. You pick up a gallon of water, it weighs about 8 pounds. Gasoline's a little bit lighter, call it 7 pounds. If you burn a gallon of gasoline, which is mostly made up of carbon, you add oxygen to it, 2 atoms of oxygen for every one of those carbon atoms, that 7 pounds becomes 20 pounds of pollution. And that 20 pounds of pollution goes into the atmosphere right out of your tailpipe and goes into the air and stays there for centuries, long after you're dead. Can you imagine that? Just burning 1 gallon of gas releases 20 pounds of pollution that could be up there for 1,000 years, maybe? That's incredible. So it turns out driving the average American car, which gets about 25 miles per gallon, driven about 15,000 miles a year, produces almost 12,000 pounds of CO2 pollution, which will last for centuries. That's about 6 tons of pollution. It's more than your car weighs, is what we put in the sky by a big margin. Fuel efficiency is crucial though. If we go from 25 miles per gallon, which is crazy low, to 50, which is just kind of modest with this day and age, we can actually take that 12,000 pounds and bring it down to something like 5,000 to 6,000 pounds. That's a good step. Planes, again, use about 1.8% of the problem here, and that's caused by just burning aviation fuel in those planes, releasing CO2 as well. But we're getting a little bit more efficient in aviation. Today's planes use about 50 to 60 miles per gallon equivalent for every passenger on the plane. It'd be like driving a hybrid car. But the problem is you're going a lot of distance really fast and you can keep doing it. So when we think about transportation, we can look at efficiency, making the current things more efficient, like fuel efficiency in cars, more efficient airplanes, more efficient trucks, and so on. And we can also look for alternatives to fossil fuel transportation, like walking, bicycling, mass transit, or video conferencing, where you don't have to go anywhere to hear other ideas or meet other people. Those are all really great. And then we can switch from a liquid kind of hydrocarbon fossil fueled vehicle to an electric vehicle. Electric cars are here to stay, they're better, they're going to be cheaper, they're going to be fun and useful and cheaper to operate. We're getting electric trains, of course, electric trucks and other things. This is really crucial. But putting this all together, efficiency of our current vehicles, shifting to other ways of getting around, and then electrifying our new vehicles, there are a lot of great solutions to transportation. Okay, let's get to buildings. They emit directly about 6% of greenhouse gas emissions, but again, they're affecting electricity, transportation, and other areas as well. But what buildings emit directly within their building envelope are primarily from residential buildings. About 2 to 1 of these emissions are from homes and apartments compared to public and commercial buildings. So we're talking a lot about homes, apartments, as well as big public buildings too. Well, we emit greenhouse gases directly from buildings in our furnaces and boilers and hot water heaters, because they're going to burn natural gas or maybe fuel oil, heating oil, things like that. And those emit CO2 right from your basement. But buildings can also release refrigerants from air conditioners and refrigerators kind of accidentally if there are any leaks in your air conditioning equipment or your refrigerators and your freezers. That's why we always should be tuning those up and watching them. In a typical American home, we actually use a lot of natural gas to heat our spaces, especially in a cold place like Minnesota, where I live, or to heat our hot water for taking showers and things like that. And we measure natural gas in what are called therms. A therm is 100,000 BTUs worth of heat, and that's what your gas meter is measuring it in. The average home in a cold part of America uses about 1,000 therms every year, and that would add up to about 13,000 pounds of CO2. More than your car in a lot of cases. So again, we have to think about electricity and transportation, but also the energy used within our buildings, often as natural gas or heating oil, in order to tackle climate change. So that's why building efficiency matters so much. A lot of buildings are still too inefficient. They leak heat out, they pour heat in during the summer. We can make buildings really much more efficient. We can always build new green buildings, of course, but we're going to have to do a lot to retrofit the hundreds of millions of buildings that already exist. Then we got to shift to new energy sources that don't burn fossil fuels to heat our homes, cool our food, and give us nice hot showers. And we've got to pay special attention to the refrigerants in air conditioners and freezers and refrigerators, because when those leak, they become a kind of super pollutant, causing disproportionate climate change. When we look here, we see energy efficiency, shifting energy resources, and addressing refrigerants are going to be the crucial aspects of buildings in climate change. Let's wrap up here. Now we've got the last sector, which is everything else, the other category, about 10%. A lot of this is from the energy sector itself when they flare off natural gas in an oil well, or what are called fugitive emissions, which are kind of the emissions that escape accidentally from a fracking well of natural gas, or a coal mine, or a leaky natural gas pipeline. These are things we should demand the energy industry address right now. These are super low-hanging fruits that if the energy industry cared at all about this, we could shut off like 6% of climate change today. So what have we learned? We've learned that attacking the sources of greenhouse gases are the first biggest step to addressing climate change. And there are big 5 areas we should be focusing on: electricity, food, industry, transportation, buildings, and so on. And we can see those here. But then inside those major sectors, we have hundreds of little areas that are all really important to address if we want to solve climate change. There's absolutely no silver bullet here. We do a lot of individual things between flying and cement and plastic, electricity and buildings and food and meat and everything else. All of those little things contribute to climate change. So we're going to have to do a lot of little things together to solve climate change. There are many sources, therefore there are many solutions. We're not going to solve climate change simply with a solar panel, or by eating less meat, or not flying, or not using cement. We've got to do a little bit of all of that stuff. And usually, one of the repeating lessons we saw here is start with efficiency. Wasting less energy, wasting less material, wasting less food. Those are all really crucial. And then switching what we do to something that doesn't emit greenhouse gases. We can still make electricity, but do it differently. We can eat food that doesn't emit greenhouse gases. We can make stuff and live in places and get around without any fossil fuels at all. So between efficiency, where we usually start, and transforming the economy to a low carbon economy, we have some great solutions to tackle climate change.
Great. Yep. So I think one of the takeaways I hope you get from that is that a lot of this technology exists already. We just need to make it happen. And Elizabeth says we need more support and action from our corporations and government, and that's true. And there's a lot of things happening at the federal level now that we'll talk. We'll introduce something to you about it next week. We talk about next week. We'll be talking about civics. We'll talk about social activism and that sort of thing. But now, if we can go to the next slide. I'm sure Lou's probably trying to get there. So the next slide is basically just like, your things to think about this week, which are things I want you to think about, like how were you affected by racism? And if if you haven't been directly affected by racism because you're not a person, you're a white person, you have been affected because by keeping people of the global majority out of our processes and out of our decision making, we're losing a lot of good ideas and a lot of life experiences we can learn from. So I want you to think about what maybe maybe the person, but by not promoting a person of the global majority to study science, that maybe that they would have invented something that would have been help us, another technology we could use to get out of this problem. And then the other thing to think about is how you how environmental justice has affected you, how corruption has affected you. And then I want you to think a little bit about how each of us this week can Lily, I think Lily used to there, Lily, which we don't see the
Oh, you don't?
no, we see your email list.
Oh,
So
that's great.
so I'm sorry.
Hold on.
I'm sorry.
Sorry,
So basic-
everybody.
That's all right. So just basically, I want you to think about like how you can bring more, Ubuntu into your world this week. I don't know if that's the right way to phrase that, but just how we can all be, kinder, more considerate, more caring, more community-based. So, so with that, that's our 8 o'clock hour. And like always, we'll keep the lines, the Zoom line open for another half hour if people want to stick around. But I also understand that a lot of you need to get out to life. So thank you for coming. And I'm sorry that I didn't see Syra here tonight. I'll find out what's going on. I hope we can get her to come back some other week. So thank you. Thank you for coming tonight.
Why is it not?
So